trillions of tons of carbon left out of the environmental model, scientists warn. This is by Yuan Huang and colleagues on The Conversation. We all know about the carbon in Earth's atmosphere and probably about the carbon contained in plants and the bodies of animals, but a substantial fraction of the carbon in the planet's land-based ecosystems is held in something so obvious we might overlook it, that is, the soil. Even if we do think about carbon in soil, we are usually thinking of carbon in organic matter in the soil, such as plant litter, bacteria, or animal waste. However, the inorganic mineral component of soil also contains carbon. In a new study just published in Science magazine, we show there is much more soil inorganic carbon than anybody realized, and that it may be a surprisingly big player in the planet's carbon cycle. We analyzed more than 200,000 soil measurements from around the world to calculate that the top 2 meters of soil, that's top 6 or 7 feet of soil, globally holds about 2.3 trillion tons of inorganic carbon. This is about 5 times more carbon than found in all the world's terrestrial vegetation. We estimate some 23 billion tons, that's 1% of this carbon, may be released over the next 30 years, with poorly understood effects on Earth's lands, waters, and atmosphere. What is soil inorganic carbon? Inorganic carbon exists in soils in various forms, and it can be trapped carbon dioxide gas, dissolved in water or other liquids, or it can be in solid form as carbonate minerals. Most of the inorganic carbon by weight is solid carbonates, often calcium carbonate, a common substance found in materials such as limestone, marble, and chalk, and they give soil a whitish look, while organic carbon makes it look dark. Soil carbonates can come either from weathering of rocks or from the reaction of soil's minerals with atmospheric carbon dioxide. Inorganic carbon tends to build up more in soil in arid and semi-arid environments such as Australia. That's because when water runs through soil, it tends to carry away some of the carbonates with it. And we have here the map showing the global distribution of inorganic carbon in the top 2 meters of soil, and you can see most of the basically arid deserted areas, the Sahara and Saudi Arabia. You can see there the Atlas Mountains of Tunisia. Now, our estimates show the top 2 meters of Australia's soil harbor some 160 billion tons, that's 7% of the world's inorganic carbon. This makes Australia home to the 5th largest pool of soil inorganic carbon in the world. In wetter regions, soil carbonates may also be found along rivers and around lakes and coastal areas in the form of calcium-rich alluvial deposits or calcareous rocks. Soils in karst regions, areas rich in rocks like limestone, and often characterized by caves and sinkholes, typically contain carbonate in rocks. In areas such as Central Asia, large deposits of wind-blown sediments, loess, contribute to the accumulation of carbonate minerals. Now, why should we care? This huge pool of carbon is affected by changes in the environment, especially soil acidification. Acids dissolve calcium carbonate, meaning the carbon dissolves in water or is sealed as carbon dioxide gas. Soil in many regions of the globe, such as China and India, is becoming more acidic due to acid rain and other pollution from industrial activities and intense farming. Scientists have viewed carbonates in soil as a relatively stable pool of carbon that changes only slowly over time. However, human activities have made soil inorganic carbon more mobile. Irrigation and fertilization of farmland speeds up the rate at which soil inorganic carbon is dissolved and leaches out of the soil. Inorganic carbon has accumulated in soil over vast periods of Earth's history. Disturbances to this carbon will have a profound impact on soil health. Disruption to this carbon compromises soil's ability to neutralize acidity, regulate nutrient levels, foster plant growth, and stabilize organic carbon, Not only does soil inorganic carbon act as a store of carbon, it also supports soil's many crucial functions in ecosystems. In our research, we found that 1.13 billion tons of inorganic carbon are lost from soils each year to inland waters. This loss has profound yet often overlooked effects on carbon transport between the land, freshwater bodies, the atmosphere, and the oceans. So, what to do about this? There's a growing recognition of the importance of soil carbon as a fundamental part of nature-based solutions to combat climate change. However, much of the focus so far has been on organic carbon. Our research shows inorganic carbon warrants equal attention. Improved land practices can reduce disturbance in the global pool of soil inorganic carbon and may even be able to make it bigger. In agriculture, making irrigation and fertilization better, adjusted to plant growth needs, can reduce impact on inorganic carbon. In some soils, organic amendments such as compost and manure can protect against acidification, improve calcium levels, and increase soil inorganic carbon. Our research shows efforts to mitigate climate change by sequestering carbon in soil must incorporate inorganic carbon as well as organic. Inorganic carbon in soil is linked to global changes such as climate change, industrial pollution, and soil reuse in different ways from those of organic carbon. However, some strategies to lock up more carbon in the soil, such as enhanced rock weathering, afforestation, and trapping organic carbon in soil minerals, might also serve to increase levels of inorganic carbon. There are already international soil carbon programs like the 4 per mile initiative, which aims to increase soil carbon storage by 0.4% annually across the globe. These efforts could further increase their ambition by considering the critical role of inorganic carbon in achieving sustainable soil management and reaching climate targets. This is from the conversation here under Creative Commons. It's by Yuanyuan Huang, Senior Research Scientist, Chinese Academy of Sciences; Pep Canadell, Chief Research Scientist, CSIRO Environment, Executive Director, Global Carbon Project, CSIRO; and Yingping Wang, Chief Research Scientist of CSIRO on Science Alert. Please leave your comments. Thank you for your support. Support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.